Welcome students, welcome to the physics class, and today we are going to discuss a beautiful topic from your physics chapter, and that is acceleration. So as you all know that we are dealing with the moving object, so this acceleration also it is related to a moving object. Now before starting the topic, let us take an example. Let us take a real life example. Suppose you are driving a car. Okay. So you are on a highway and you are just increasing the speed. That means this is your car and initially it was at 30 kilometer per hour. The speed of the car was 30 kilometer per hour. Now after 10 minutes, the speed of the car increased to 40 kilometer per hour. And again after 10 minutes, the car speed up to 50 kilometer per hour. That means at every 10 minutes interval, the car is increasing its speed, and that means the speed is increased by 10 kilometer per hour at every 10 minutes. That means here the speed is increasing. That means the car is accelerating. Now here the word accelerating comes. So by this example, we can understand the acceleration. That means in this case, the car is increasing its speed at every 10 minutes interval. That means acceleration means whenever the car is increasing its speed with respect to time, that is acceleration. Now, suppose you are driving a car and suddenly for some reason you need to apply the brake. Now in that case, suppose the speed was 50 km per hour. Now when you apply the brake at every 10 minutes interval, the speed of the car decreases by 10 km. See, at 50 km per hour the car was. Now after 10 minutes the speed of the car becomes 40 km per hour, and again after 10 minutes the speed of the car becomes 30 km per hour. So in this case the speed of the car is decreasing, and this is called retardation. That means we will tell that yes, the car is in deceleration or retardation. The word deceleration and retardation is very much similar thing. So by this example we can see that the velocity changes with respect to time. So here in these two examples we can see that the velocity is changing with respect to time. Now in the first example you can see the velocity increases. In the first example you can see the velocity increases with respect to time. And when the velocity increases with respect to time, that means acceleration is taking place. Whereas when the velocity decreases with respect to time, and that is retardation. Okay. So here as the example has been taken, so let a car moving with a velocity with initial velocity u, and after time t the final velocity becomes v. So now we are going to derive the formula of acceleration. So initially the car was moving with a velocity u. Now after time t the velocity of the car become v. Okay. So the formula of the acceleration is, now the formula is change in velocity by time. The formula is change in velocity by time. Now in acceleration case, we know that velocity increases with respect to time. Now when velocity increases with respect to time, then obviously we can say that final velocity will be greater than initial velocity. Since the velocity increases, so final velocity will be increased. So in that case, we will subtract initial velocity from final velocity. So in case of acceleration, we will subtract initial velocity from final velocity. So final velocity minus initial velocity by time. This is the formula of acceleration. So the formula of acceleration is v minus u by t. V is the final velocity, u is the initial velocity, and t is the time. Now, if we check the retardation case, retardation means when the velocity decreases with respect to time. Now, when the velocity decreases with respect to time, then we can say the initial velocity will be greater than final velocity. Since we are applying the brake, initially we have higher velocity. Now, when we apply the brake, then the car or the thing that we are riding, that will decrease its speed as you are applying the brake. So in that case, the initial velocity will be greater than the final velocity. So in case of retardation, we will subtract the final velocity from the initial velocity. So in case of retardation, initial velocity minus final velocity by time. And so the formula of R is u minus v by t. Now if you compare these two relation, we can say acceleration is equals to negative of retardation. That thing we can say. So there is a opposite relationship. That means there is a negative relationship between the two. That acceleration is equals to minus of retardation. So I think up to this it is clear to all of you. Okay. So this is about acceleration. Now we will talk about the unit of acceleration. Now unit of acceleration means, now see, unit of acceleration is actually, the formula is the unit of change in velocity by unit of time. Now in that case, if we see the formula, that means acceleration is equals to change in velocity by time. So we have to put the unit of change in velocity by time. Now change in velocity, the unit is kilometer per hour, simply the unit of velocity, and we know that unit of velocity is kilometer per hour or meter per second or centimeter per second. So here I have used kilometer per hour and unit of time is hour. So kilometer per hour square, this is the unit of acceleration. The same way, meter per second square will be the acceleration, and that will be the SI unit of acceleration, and centimeter per second square, it is the cbse unit of acceleration. So this is the unit of acceleration. So this is all about the theory part of the acceleration. So what we have studied the that means the definition of acceleration. We have taken some examples and we have discussed that how the acceleration is taking place. Okay, so let's now take one numerical. Now here a numerical question is there. So a car start to move from rest and attain a velocity of 60 km per hour in 10 seconds. So the body start its motion, that means the car start its motion from rest. So initially the body was at rest, the car was at rest. Now after 10 seconds it attains the velocity of 60 km per hour. Now find the acceleration produced by the car. We have to find the acceleration produced by the car. So initially the car was at rest, so the initial velocity will be 0 km per hour, as you can see. Now final velocity will be 60 km per hour. Now this 60 km per hour, this velocity has been attained by the car in the time interval of 10 seconds. Now 10 seconds, we have to convert it into hours, since the velocity, the unit is given in kilometer per hour. So we have to convert this 10 second into hour. Or another thing you can do, you can convert this kilometer per hour into meter per second. Then also you can do that. Also you can do, and the formula will come. Sorry, extremely sorry. This will not be the square. Okay, so wait a minute. Meter per second. The unit will be meter per second, the velocity, and in that case the time we will keep the unit as in second only. So in that case the acceleration will be final velocity minus initial velocity by time. So here, since we have I have keep the unit of velocity as kilometer per hour. So I have used kilometer per hour square here, unit, so you have to careful about the unit also. So I have put the value and I have got the result as it is 21,600 kilometer per hour. Okay, so this way you have to solve the numericals. Simply you will use the formula here and you will find out the result. Okay, so I think this topic acceleration is clear to all of you, and I am ending this video here. Thank you.